Hi there, my name is Shivdat, and today we're going to be looking at a very interesting math problem about finding one lighter ball in a big set of balls. You may have come across this problem in various forms before. It's a very common interview question, but we'll try and generalize it a little more to see, it's often in interviews it's kind of left at a premature stage. We'll generalize the result a little more to see a very interesting pattern. Alright, so the problem is as follows. You may very well have seen it before. You have 8 balls, right, and a balance, a weighing scale, and one of those 8 balls is lighter than the others. And the question is to find that lighter ball using a balance with as few uses of the balance as possible. So you have 1, 2, 8 balls, you have a balance, right? You can put however many balls in each balance and weigh them. And the answer is to find the lightest possible ball. So if you want to try and work at this, if you haven't seen this before, now is a great time to pause the video. Alright, so after playing around with it a little bit, you might come to the answer 3, maybe. Is it possible to do better than 3? So 3 is simple. Say you put 2 balls in here, 2 balls in here, and you have 1, 2, 3, 4 balls left, right? 8 balls in total. Now if these are equal, you know the lighter ball is going to be in these. If these were not equal, whichever is lighter, you pick that set and you can find the lighter ball, but just by one comparison more. So if these were not equal, it would take 2 chances. If these were equal, they're left with 4 balls and you can repeat the same thing, and that would be 3 chances. But you can actually do better. What if you use 3 balls at a time, right? And so we remove 2 of these. Now, if these were the same, then you know the lighter ball is among these 2. You can weigh these 2 and find the lighter ball. 2 chances. If one of these is lighter, one of these sets is lighter, then you know the lighter ball is really in one of these sets. So supposing this set was lighter, then the lighter ball is in one of these sets. You can take 2 of these 3 balls, weigh them. If they're equal, then it's the 3rd ball that's the lightest. And if they're not, then one of them is lighter than the other, and that's the lightest ball. So really you need 2 chances for 8 balls. You probably found this. Now what if I change the answer to the question to have 9 balls rather than 8 balls? So, 9. Good time to pause the video and think about it if you'd like. So 9 balls is really the same problem, right? I would repeat the problem with weighing 3 at a time, and I have 3 outside instead of 2. And the same thing, if one of these is lighter than the other, I can find it just by taking that set and comparing 2 of them. And if these are the same, I know the lighter ball is in this set, and I can find the answer by comparing any 2 of them. Alright, so we've seen 9 balls basically requires 2 turns. How many if I give you the problem with 10 balls, how many turns would it require? So now you can try various combinations. A great time to pause the video again if you want to think some more about it. But you'll find that with 10 balls you really can't take 2 turns. You need 3 turns. So 10 balls takes 3 turns. So is there some way to generalize what we've seen here? So many interviews stop at this point, right? They'll give you a certain number of balls, they'll ask you the minimum number of comparisons to find the lighter ball. You may get the wrong answer, you may get the right answer, that's it, end of the story. But let's try and generalize this, let's be a little more general. What can we say about, if I were to give you X number of turns, what's the maximum number of balls that I could, find the lighter ball from with that many turns? So let's try and answer this question. Now would be a good time to pause the video if you want to think more about it. Basically, you see that 9 balls is the stopping point for requiring 2 turns. 10 balls requires 3 turns. You can try, you'll never be able to find the lighter ball from 10 balls with surety with 2 turns. And 11 balls will also require 3 turns, and you can keep going on. The thing is, when do we draw the line? When does 4 turns start? It's a great time to pause the video and think about it. And if you need a hint, I would suggest looking at this example and what we did here. Alright, so the basic idea is you really want to split, the best way to attack these problems is to split the number of balls into 3 different sets. Now you may say it's not divisible, the number of balls is not divisible by 3, but notice we're solving the other problem. We're given the number of turns and we want to find the maximum number of balls, and it will turn out that the maximum number of balls for a given number of turns is divisible by 3. Because say you had n balls here, n balls here, n balls here. Or how about this? Say we know that with 2 turns the maximum number of balls you can do is 9. So just imagine we had 3 sets of 9. We had 9 here, 9 here, and 9 here. Now to find the lightest from this 9 would require to find the lightest from 9 balls would require 2 turns, right, as we've discussed. To find the lightest from 9 balls would require 2 turns. To find the lightest from 9 balls would require 2 turns. And we're left with 3 balls, right? The lightest from each of them. And we can find the lightest from that with just 1 turn by comparing 2 of them, just as we discussed. So really, the maximum we can do with 3 turns is have a set of 9, 9, 9, 27 turns. Or 27 balls rather, sorry. Similarly, once we've done that 27, right? If we have 4 turns, we can have 3 sets of 27. And the maximum number of balls will be 27 plus 27 plus 27, which is 81. So we can do 81 balls with 4 turns, 21 balls with 3 turns. And so you see the pattern now, right? 2 turns will be 3 to the power 2. 3 turns will be 3 to the power 3. 4 turns will be 3 to the power 4, 81. And n turns will be 3 to the power n. So in other words, the maximum number of balls from which you can find the lightest with n turns is 3 to the power n. So if I were to give you, if any interviewer was to ever give you a number of balls, and he asked you to find the maximum number of turns you need to find the ball, you can always know what the answer is by comparing it to 3 to the power n and seeing if it's lighter or it's bigger or smaller. So next time you go for an interview and you see, you don't have to memorize the result for 8 balls or how you got the result. You can just remember this more general version, and whether he gives you 265 balls or 523, all you have to do is 3 to the power n, compare the result, and you'll know how many turns are required. Thank you, I hope you enjoyed it.